Marinel Marian, Dream Downloading Crash Course. Okay, you both need microphones? Yeah. Okay, then you will have mine.
Nu? Merge. Oare de ce nu se vede pe ecran? Nu se vede pe ecran prezentarea noastră. Hello? Hello? Hi.
1, 2, 1, 2. Okay.
Yeah, so can you hear me? Okay. Hi. Hi everyone. Today Marinel and I will present something called Dream Downloading Crash Course. So basically, let's see what's behind this fancy title. The presentation will be divided in a few parts. I will present the generative search engines and how they are taking over the world. I'll also go into a bit of a theory, and I'll explain why we did this research. Then I'll show the approach that we had and the discovery process and what results out of it. We will show a live demo, hopefully a very interesting one, and we'll finish by some conclusions and some questions, food for thought. So this is us. I'm Radu and Marinel. We are working at Endava, and that's very important. This project is an internal funded project, so the aim is to show that we can do some interesting research, but it's not a product itself, and it's also not something developed for a customer. That's why we are able to share so many details. Also, the project was internally funded, as I said, by the gaming branch that Endava has, which already has 15 years of experience in developing games. So, I don't know about your bubbles, but in mine, generative search engines are everywhere. And during the last months, maybe you heard, but lots of them appeared like mushrooms after the rain, as we say. So there is, first of all, DALI, then DALI Mini, then Midjourney, Stable Diffusion, which is growing very fast, Disco Diffusion, Palm, Lambda, Imagine, Party, Make a Scene, lots of them. So all of these are solutions to create text, images from text. For example, DALI, one of the first, was able to create astonishing images like this one. Also, that's impressive, and I was shocked at the beginning when I saw this, how it takes into account all the reflections and all the light changes into the scene. Then came Stable Diffusion, which is even better because it's free, it's open source, and another reason is that it was trained on a more aesthetic set of images, so it produces better quality images. Here are some examples showing you the art of the possible. These are some images created by a friend of mine who used Midjourney to create them. Then this is one of our colleagues who used as a prompt a lullaby, and this is the resulting image in Midjourney. Then these are some other images that are being published continuously by creators on different channels, and I think they can prove the high quality that image generators are able to provide. Also, regarding Stable Diffusion, that's interesting to note that there are so many different features that are being developed by the open source community. For example, the in-painting ability can help create different things, different links between images, or you can train a specific template and then replicate, for example, a person. In this case, that's Oprah, which is part of a cartoon as a character. Also, the open source community makes possible to run Stable Diffusion on a GPU, on a single laptop, and the images are really increasing in quality and in resolution. With all this in mind, I will walk you through a bit of theory so that we all understand a little bit how these models work. Basically, the three characteristics that they respect, they combine, the three directions are zero data learning, meaning that you don't have to train specifically a model to get some results. It's able to extrapolate from the training data. Natural language understanding. This is the quality of a model to understand human language, like sentences. And multimodal learning, which is the ability to learn from different sources, in this case mainly from text and images. Latent space is another notion that's very common and found everywhere in image generators. And basically it's a representation of data in a compressed space. But what's nice about that is that you can have embeddings, so representations in the latent space, both of images and of text. And if you think about overlapping or finding out a relationship between text and images, like the guys from OpenAI did when creating Clip, you can create something extraordinary which is able to provide a picture that corresponds to a description and also the degree of overlap between the two. And this goes both ways. StyleGun is a adversarial network, a generative adversarial network, which was able to produce very realistic images. And the nice thing when producing such an image is to be able to influence some characteristic of the image. And in this case, this is called disentanglement. So in this case, if you're able to just alter the facial expression or the hair, this means you can have a really direct influence on the final image. So in this case, you can see some examples. You can see how the faces are changed according to the prompt, or, well, in all these examples, I won't enter into details, but these are examples of disentanglement in which you can just change one specific characteristic of the image. Well, combining style gun with clip resulted style clip, which is a way in which the images could be manipulated even better. And text to mesh is a step further, which enables not only to manipulate 2D images, but reach to 3D objects. Okay, so this was the bit of theory, I hope not too boring. Now let's see why we did the research. So we went to our colleagues from the game department and asked them what were their main problems and struggles. And one of the most common struggles of an art designer is that they have to sculpt meshes. They really have to go into details and work a lot on a mesh in order to alter an object. In this case, if you imagine if you have this gargouille and you'd like to have it grow some horns or some bigger wings, it would be much more difficult to do it manually than to do it just by text. It would be great to say, grow some wings. So, thinking about this, we thought that a method to alter a 3D object by voice, by natural language, would have at least these three characteristics, three benefits. It would provide creative inspiration influenced by the artist. It would accelerate the asset production. And in an ideal world, it would be able to create 3D objects ready to use in games. So the challenge is here. There are many factors that play into favor of this idea. So we try to understand how we can support our colleagues and help them save valuable time. As Endava is a large company, we were able to gather a strong team of data scientists, UI developers, graphic designers, MLOps, gaming, subject matter experts. So we all gathered in order to try to find out a solution for this problem. Now, looking at the pipeline of production of a game, you have the concept in which you have the 2D concept art, the 3D concept art, then the modeling, the texturing, the animation, and the rendering engine. We, with this idea, are able to impact on the first three steps. So what was our approach? We started by an analysis period, then we went through the discovery phase, we built the POC, we evaluated it, and we went through a product phase, which actually we postponed because this is not a product. It's important to underline here that all the process took just 3 months, from November to February, and we had this also the winter holidays in the middle, so that was quite a quick generation. So the analysis and discovery implied reading through a lot of academic papers, and we filtered them through 2 filters, usability and suitability. What we found is that just this text-to-mesh approach was both usable and suitable for our needs, and we decided to go on and use that. So after contacting the authors, correcting the code, fixing all the bugs that were there, we were able to start from a 3D mesh, then input the prompt, in this case a hiking boot, and the method produced what you see in the middle. This is a series of iterations that led to this object. And finally, the artist on our side did some post-processing and we got the final object. Here are some examples of different prompt combinations and the results that we got. So you can see here a massive broccoli horse, and if you ever wondered how a strawberry horse looks like, that's how it is. So we experimented with parameters, we added different dimensions, and we got these type of results. Of course, not everything is so smooth, so we also had due to the number of parameters and the complexity. We had some monstrous examples, so you can get a useful elf figure, but also some pretty useless images. An interesting observation is that the 3D mesh and the model that we are using has a semantic understanding. So the body is not equal. It's not textured in an equal manner. The legs and or the torso have a different texture, which actually suits the reality. In the case of having a whole body with the head and the rest of the body, we discovered that the head was pretty ugly. So instead of applying the method to the whole body, we split it, we chopped the head, and we applied the beautification to the head itself, and then to the body. And then we stuck together both things. In this case, it proved to be a better result, which would be really useful in real life too. So if we look at the idea of the head, this is a man with a goatee. So the prompt is to grow some beard on the face of a man, and you can see it really grows in the proper place. Trying to use an image as a prompt, we also got some results, not so good, but that's also interesting to share that there are things that can be improved. Other interesting observations are related to the quality of the mesh. Depending on how it's structured, depending on the topology, we can get different textures and geometric deformations. Also, for those that are familiar with 3D objects, the skin of the object is mapped into something called UV map, and the original method produced a scrambled, like this kind of omelette-looking map. But we remapped that, and we managed to build a better one suitable for our artist colleagues to color better the objects. Other problems with such methods are spikes. Sometimes when the mesh grows, it gets some spikes that are really useless. So we also developed a method to detect when the spikes appear and then stop the process. Here are some examples of objects with different themes and colors. You can imagine them into games. And we developed another original method which is able to fine-tune objects. So basically you should wait for about 20 minutes to get a final object. But in this case, after going through the whole process, we developed a method that is able to interpolate, to kind of slide between different variants of the object. So you can choose the geometry that you like with the texture that you like, and you get the best object. Here is an example of how we did an UI using this idea. So you start by entering the prompt, and then there are some hidden parameters that are also editable. This is, of course, a fast-forward version of the iterations. It will usually take about 20 minutes to go from a smooth donut mesh to a final donut like this one, like a medieval ring. But once you have the object, you can choose which one you want to interpolate with. So in this case, the first object is the source object, and the last one was chosen as target object. But you can do this by choosing two different objects. So you can basically slide between the two and get real-time deformations. Anyway, if anybody is interested, I will provide more details after the presentation or after lunch. And moving on to evaluation, which is the most interesting part, is what we did and how we judged our own results. We presented the outcome to our colleague, to our colleagues in the art department, and basically they took it, they took the output of the method after only 4 hours, which might seem long. They created the mesh, and from the mesh they created the usable 3D nice looking object. They did the same with the fox head, and you can see that the artist added his own ideas to the mesh. And this is also interesting in the case of the broccoli of the grass horse. The artist imagined the body of the horse as stone, and then the grass like this. This is another example with the frog man. So what I would like to highlight here is that even if it seems a lot, like the work they had for the mesh and for the texture, we actually asked them to estimate how long would they work if they didn't have our tool. And their estimations were much higher than what they were able to achieve. So now I showed you how we can create objects. Now let's see how we can build stories. And I'll pass the mic to Marinel.
Can you hear me? Cool. Yeah, so dream downloading crash course. What's that all about? Well, I'm thinking of this problem. I'm thinking of the fact that I have some ideas and I want to explore what their potential is and maybe what kind of alternatives I should consider from that particular idea. So it sounds a bit abstract, but what we're thinking is how can we actually take whatever is in our head and put it in front of us and maybe share it with other people. So in order to do this, we need to solve, to solve this problem, I'm thinking that we're going to need, first of all, a large language model that is able to understand some guidance from me. And for this particular purpose, I have chosen GPT-3 as the large language model. Also, to be able to illustrate a narrative, I want to use a model that is able to generate images based on prompt text. So, Radu mentioned before this DALL-E 2, that is able to create beautiful images and also stable diffusion. And these two are really, really great models into painting whatever we are describing. So I have integrated these two, let's say, systems, like the large language model and this generative search engine. And basically, I'm trying to create a story. And I have an idea in my head. I want to put it in front of my eyes. And therefore, I created a web application that integrates these two. And it's building narratives. It's building stories. So I have prepared 2 stories already for you. And if we go for the first one, I imagine that it's called The Nest. And the synopsis of the story says like it's a fleet of 3 starships that head towards a new planet with the hopes of colonizing it. And the long journey exposes them to new discoveries that alter the entire purpose of their mission. So this is an idea that I had, and I said, oh, well, what can I extract out of this, and how can I build upon it? So in here, there's one experiment that I did, and you can now see it with me. So I've explored multiple avenues of ideas, whether I should have like 3 main characters or considering that it's a long journey, maybe after a 10-year journey, it says here that the 3 starships finally arrive at the target planet, and the crew is excited. And basically, from this, I can also explore variants or branch out multiple alternatives or alternative endings to the story. Also, what's really important is the fact that I have chosen for this particular story to be drawn in the drawing style of anime illustration. So what this means is basically that all the images that are being generated are going to follow this particular guidance. It's an anime, and basically, as you can see here, all the images that are being generated are in this style. So, for example, this continuation, this one, it tells about the planet that has everything that they have hoped for and more, and the crew was able to stretch their legs and explore to their heart's content. And they quickly realized that this is a really beautiful and full of resource planet. This is one way to go with the story. But another way is when you are approaching with the ship, you're hovering over the planet and you're looking at green forests and everything. So what I wanted to showcase here is the fact that I can generate continuously other alternatives and the stories may branch off, may branch out in the sense that, for example, this exploration, this benign exploration ends up with actually encountering some aliens or some inhabitants of the planet. And therefore, the model that generates this continuation is taking me with the story to a road where I am meeting aliens and I need to solve any kind of problems that I can have with those. So what I wanted to mention is the fact that while this is really cool to play around with and to explore your ideas, I have also created another story, another seed of the story. And this time I chose a bit childish, let's say, a theme, like a Disney cartoon, where 2 kids spend their winter holidays at their chalet in the snowy mountains of Austria, and during their hike they discover the beauty of the nature. So, they also make friends with a fluffy bunny and a baby deer. So if I am expanding this particular story, I can see here that the story starts with describing the 2 kids that are called Max and Emma. This is something that I haven't come up with. This is what the large language model has generated for me. And based on this particular prompt, I can ask it to draw pictures. So, for example, I can see here other versions of the pictures that have been drawn based on this particular paragraph. So I'm choosing the one that fits the best let's say, the thing that I have in my head, and I can move on to create another continuation. And what's saying here is that on their first day of hiking, Max and Emma discovered the beauty of the nature. So basically now they are befriending a deer, and this is again, the continuation is based on the title of the story, is based on the summary of the story so far, and is also based on the last paragraph, so that it has it follows the natural continuation. So if I want to see, let's say, the story, like what's the end result of this? I mean, I'm exploring, that's fine, but how can I see the end result? So if, for example, I'm looking at this particular thread, I can see here the first picture, right? The happy winter holidays story with these two paragraphs that are describing or that are beginning the story. So having all this and having all this capability, I want now to together with you to create a new story. And basically, what I'm going to do now is everything is live. It's on localhost, as you can see. So it's a web app. If things go wrong, well, then the Domo gods are not with me. So let me quickly start typing or creating this new story. And in order not to see me type or do typos and all this, I have prepared like a title. And for example, I've said here, The Lord of the Rings, Quest for the Dragon's Lair. So this is one title that I'm thinking. And again, for a synopsis, I have selected like something that might sound interesting, like Frodo and his companions set out for finding the lair of the dragon hidden in the Black Mountain. So on their way, they face dangers and fight trolls and giants, but they have the help of friendly elf people. So this is the seed that I'm giving to it. And now I want to choose a drawing style. Why do I want to choose this? Because I want to give it like a, how can I say, a feeling of something that resembles what's in my head. And I have stumbled upon this guy called Greg Rutkowski, who's really good at drawing stuff, and it draws some very, very beautiful pictures. So I have selected this particular style and say, okay, please draw me now based on the synopsis that I've given to you, and in the style of Greg Rutkowski, paint me something that resembles this particular description of the story. And right now, as you can see, it takes a bit of time to actually get the results, but finally we're going to see the end result being generated by these models. And what I wanted to tell you about this is that DALL-E 2 and as Radu mentioned before, Stable Diffusion are two very different engines, but they are aiming for the same goal. For example, DALL-E 2 gives me like a cartoonish like image, and for example, Stable Diffusion is trying to paint something more, let's say, more accurate or more into the feeling of Lord of the Rings, probably because it has been trained with images similar to something like this. So we can see other choices. This is also DALL-E 2 generating it. Look, this is another sort of picture, like a painting of some sort, and yeah, another version. So out of these, I think that maybe we can go with this one because it sounds like Lord of the Rings and it looks a bit like that. So based on this, I want to create a continuation from it, and I want to explore, okay, from this particular description of the story, how would the first paragraph sound like? And let's see. Okay, so it says here like this. Frodo and his companions set out on a quest, right? So this is the beginning of the story, and there's a direct correlation between I gave it a description, and now I want to start the story. So pretty much they're going to be looking alike. But once we are getting past the first paragraph, we're going to explore more and more what the large language model thinks about this story and how it decides to move towards to. So, for example, now I'm asking it also to draw me a picture of this particular quest, and let's see if DALL-E is doing something. Yeah. So we can see here like a drawing that DALL-E did, and also this is the Stable Diffusion. And we can also see other. So this looks also like a quest. Yeah, this one too. So I want to be faithful to, let's say, the first image. So I think the most appropriate would be this one. And for example, I can ask it to continue a bit more. So now they are starting a quest, right? And we want to see where does this take us. So one moment. Okay. Okay. Yeah. So it says here like as they journeyed on the landscape became increasingly treacherous, but they soon found themselves within sight of the dragon's lair. They could see a large dragon resting on a pile of treasure and knew what they would have to be very careful to get past it. So, for example, this one takes us a bit further, and as you can see, I haven't intervened in any meaningful way so far. What I just did is just chose to continue and ask it to draw something to me. So if, for example, I'm not satisfied with this particular continuation and I want to see something else, okay, I can create an alternative. And for example, I can see here the story branching out. So there's another branch, and if I'm not satisfied with this, I can also intervene here, and I can actually override manually the story. So for example, I can, whatever it says there, I say I'm not happy with it, so I'm placing something else, like they were captured by the trolls and locked into their underground cave, but were saved by the spirit of the black bear. Tell me another animal and another color, just to put it in here. What? Deer? White deer? Okay, white deer. I thought it was white beer, and I was like, oh. Okay. Yeah, it's just water. Okay, so I'm going to ask it now to draw us a white deer with the capturing of the trolls and everything. So once I do this, what I wanted to show you is the fact that we can combine these amazing tools to actually help us ideate, help us explore the ideas, and basically help us get inspired. So let's see what the end result is. And with this, I'm going to finish off the demo. So, oh, look, there are some deers here, indeed. Oh, this is nice. So, as you can see, it gave, let's say, a voice in some sort of what I have tried to express. So, I hope you've enjoyed it, and I hope you can see the potential of these tools. This is just a demo to understand how to integrate this into something that can make that can be meaningful and can be inspiring. So let's go to the conclusions. Thank you.
Now, if you hear me, I'll go really quickly because the conclusions are what is left to the lunch. So, well, what can we see? That such methods can provide a creative inspiration that can be still influenced by the artist. They can be used as promising results for accelerating the asset production, or we can use directly these into games. Now, what we could think about next is how can we make these models more cognitive, more aware of the context. We could use the style transfer and define some personalized models. We can build context-aware models in the same way as Google takes into account the location for making a search. They should take into account the context of the user for creating the image or the object. And then what we call the elephant in the room is where is this investment going to come from? From publishers, from service providers, from startups, big software companies. Who is going to pay for all these advances? And this is a page containing some questions that could lead to 8-10 hours of debates and discussions. So I don't know, if you want, we can start now, or we can go to lunch in 4 minutes. But here are some of the questions. Who owns the rights of a generated image? Or is it needed to do something like a blockchain to understand how specific piece of art was created, can artists opt out and say, I don't want to be included in the training? If I'm Greg Rutkowski, maybe I'm pissed that everybody is doing images like my style. Inspiration versus piracy. Where is the limit? Where's the edge between inspiration and copying? Bias versus well-balanced AI. For example, if you say generate an image of a CEO, you don't want always to have a white male in a suit. And that's what DALL-E is fighting with. They are trying to find tools to create, in a debatable way, more variety of answers. And then, does AI understand art? And this is an experiment in which Gary Marcus created an image asking for a bicycle and labeled the parts that roll on the ground. So what are the parts that roll on the ground? The model should be able to understand that's about the wheels, but it doesn't work. So obviously these models are not aware of the semantics, but just pattern findings and creating images in nice ways. So all these questions are here in the wild, and these are things that the community is writing about, is talking about, and I thought it was interesting for you to know. So that's it. That's it from us. Thank you, and dare to dream.
If you have any questions, we're happy to answer. Just one. Okay.
One question.
One question. What's the winning question? Okay, go ahead. No one.
Okay, so we have time for one question. Sorin? Okay.
Hi, and thanks for the very nice presentation. We salute your efforts to try all of this. One question regarding the text generation.
Yep.
You said you use GPT-3
Yeah.
kind of libraries. How many different text outputs are you able to generate from the same input?
Well, as many as GPT...
With images,
Yeah.
With images, it's simpler to get kind of different renditions. But how many different outputs with text are you able to generate with the same input? And this is a genuine question because we've kind of tried it in one of the software projects that we did, and the variety wasn't...
It wasn't that great.
Rich
Yeah,
as we
yeah.
hoped.
Well, what I can tell you is indeed I have stumbled upon this particular limit in the sense that it generates sometimes very similar outputs over and over and over again. And I've struggled with it a little bit. And what I've done is basically I fine-tuned the prompt in such a way, or let's say to encourage it to go off course more often. And for example, if you have also worked with GPT-3, you might know that the temperature could be a factor, and there can be other parameters that help. What I've also done is to be able to stay still relevant, I had to summarize whatever paragraphs I have had before in such a way that the GPT-3 is still aware of maybe there are 3 characters in the story, maybe something happened along the way, and it needs to refer back to whatever happened in the past. So from this perspective, there was a lot of trial and error to reach these results, and I cannot tell you for sure how can I make it be original every time, because it's a closed system. I mean, it's not open to understanding, let's say, to be able to reason about it, like for a program, for example. So in this respect, this is what I can give you. A lot of trial and errors and prompt fine-tuning.
Exactly, because this is one of the main challenges that I guess, if you look at the economic aspect of it, if you try to monetize this type of AI when it comes to content, to text, not images, monetizing it is kind of a big challenge, because a lot of advertisers, for instance, would try to kind of start it from similar input to multiply the outputs and then kind of try to monetize each and every single one of them, like creating ads or creating, just building creative content for marketeers and stuff like that.
Yeah, indeed.
That would be an awesome kind of economic model.
Yeah,
but it's not as easy as one would hope. So it's still in very experimental stage.
Yeah,
so it's easy to create one story, sell it once. Okay, if it's nice, then.
But at the other end of the spectrum, it helps you in the ideation process, because sometimes it goes really off course and you haven't considered about going in that particular direction, and this actually inspires you to, oh, I haven't thought about this. Let me explore this a bit because it sounds interesting. And I can think about GPT-3 like an assistant, a muse, if you can say, and a muse as a service, right? I can invoke it, please give me something different. And sometimes it gives you really good pointers. And for example, look, the image generation, right? The image prompts. I have tried it myself to just use the paragraph as it was, and it wasn't good. And what I've done, I used the GPT-3 to actually help me extract the visual details that might be relevant from that particular paragraph, and use those to actually generate the image. Like, for example, the two main characters are walking down the path. But, for example, I'm asking, please describe the background, describe the weather, describe something, whether they're, I don't know, on horses or on foot or something like this. And then it gives you more, and then you have more to work with. And it really, I mean, I got really excited when I've seen this kind of results developing along the way.
Thank you. Can anybody use GPT-3? Is it publicly accessible by someone in the room?
Yeah, it is.
It is?
It is.
Okay. Thank you.
It is, and also DALL-E is available. However, the API for DALL-E is not yet publicly available, and that's a bit of a problem right now.
Because at some point you needed kind of a special application in order to be granted access.
Yeah, you need some access, indeed.
Thank you very much.
Oh.
Good luck.
Thank you. Thank you for the question.
Thank you. Okay, so thank you for your presentation. That was the last question. We need to take the lunch break right now, so we have to get out of the building on the stairs and inside the building to get in the restaurant.